Hello students, now we are going to discuss about the open chain structure of glucose as to how it was formulated. So, for knowing the open chain structure of glucose, there were various reactions which were performed. Let's see the reaction one by one. The first reaction, when glucose was treated with HI, that is a reduction of glucose. We took glucose molecule, we treated it with HI in the presence of heat for 2 to 3 hours, also referred as prolonged heating. Now, what do we get? We got a compound that was nothing but N-hexane. And what did this signify? That glucose consists of 6 carbon atoms and they are attached in straight chain. So, first draw 6 carbon atoms. So, herein we have our 6 carbon atoms. Let's understand the next reaction. The next reaction said that whenever we treated glucose with hydroxylamine and hydrogen cyanide, we got some compounds, that is on glucose plus hydroxylamine. It gave a corresponding oxime called as glucoxime. Similarly, when glucose was treated with hydrogen cyanide, it gave a compound called as glucose cyanohydrin. And both of these reactions proved a very basic point, that glucose consists of a carbonyl group. Might be it is aldehyde or might be it is ketone. Next, we already have 6 carbon atoms. Let's understand the next reaction. The next reaction says when glucose was treated with bromine water. So, glucose on treatment with bromine water gave us a compound called as gluconic acid, wherein gluconic acid consists of one COOH group. Now, a point to remember over here is bromine is a mild oxidizing agent and we have 2 carbonyl groups, either a aldehyde or either a ketone. Being a mild oxidizing agent, this compound could not react with ketone and hence our compound, which is a carbonyl group, has to be a aldehyde. It cannot be a ketone, so we draw an aldehydic group over to our carbon chain. Next, moving further, next reaction suggested that when glucose was treated with nitric acid, we obtained a compound that was called as glucaric acid, wherein there are 2 COOH group. Now, we all know nitric acid is a strong oxidizing agent. So what we would do, we can just confirm that alcohol would get converted into carboxylic acid. But remember, the number of carbon atom, is it same? Yes, it is. That means we could not have a secondary alcohol. Why so? Because secondary alcohol would get converted into ketone, and ketone on conversion to carboxylic acid is 1 carbon less. So we are having a group that is nothing but a primary alcoholic group, and always a primary alcoholic group has to be onto the last carbon or onto the terminal carbon. 1 terminal carbon is already booked by aldehyde, so obviously last is alcohol. Moving further, the last reaction suggested that when glucose was treated with acetic anhydride, let's see what happens. Glucose plus acetic anhydride gives us a compound, that is glucose pentaacetate. That means it is a pentaester compound. We all know that glucose consists of 5 OH groups. Therefore, it was forming a pentaester. But a point which we should understand over here is, out of the 5 groups, 1 OH group is in primary alcohol, and we are still remaining with 4 carbons and 4 OH groups. As glucose is a stable molecule, it cannot be a geminal diol. Thus, we can definitely say that in this case, glucose is having all the OH groups on different carbon atom. And now, lastly, when we satisfy the valencies with hydrogen, we get a structure called as the structure of glucose. This was all with this module. Meet you in the next module. Till then, thank you, students.